Okay, so it's time for us to start 1.1 in your book. It's about linear equations and rational equations. So we start off with linear equations. Hopefully some of this you might be rusty about it, but hopefully some of it will be familiar from the past. In any case, whether it is or not, let's get started. So we've got linear equations. Um, I don't need that. Let me get the regular pen. Here we go. Linear equations. Okay. So this is our first one. We might only need one. Let's see what happens. So problem number one. Okay. Problem number one says 2x minus 5. 2x minus 5 is equal to 15. We've got to solve for x. So if it says anything on your paper, they're good enough to put something on your paper, they're going to say solve for x. All right, how do you do that? We got to isolate x. We got to get rid of the minus 5, and we got to get rid of the 2. We get rid of whatever's plussing or minusing from the x is what you get rid of first, and then you get rid of whatever's multiplying the x, the coefficient of x. Well, so getting rid of minus 5 is to do a plus 5. Plus 5 on one side and plus 5 on the other. This is gone. We get 2x is equal to 20. Now we got to get rid of the 2. Divide by 2 left, divide by 2 on right. You get x equals 10, and there's the solution to the problem. If you want to go check it, take that x, put it in here, and see if the equation turns out to be equal on both sides. That's if you want to check it. Okay, now let's use every bit of piece of paper that we can. Why not? So let's now try problem number 2, a little bit more complex. What if you have x's on both sides? So we start out with 3x plus 7 is equal to 2x plus 9. Now we have x's on both sides. So you can't have x's on both sides. We'll go nowhere with that. We got to pick on one of these x's and get rid of them. I usually pick on the smaller one. You don't have to. You can pick on either one, but you got to get rid of one of them. So 2x is, I'm going to get rid of 2x. How do I get rid of 2x? Minus 2x will make it turn into 0. Whatever you do to one side of the equation, never forget this, whenever you do to one side of the equation, you got to do the other. When we did the plus 5 and the plus 5, what I do to one side of the equation, I got to do to the other side of the equation. What I do to one side of the equation, I got to do to the other side of the equation. Okay, this will be gone. We'll have 9 on the right-hand side. So that's good. 3x minus 2x turns out to be just plain 1x plus 7. We're not done. We've got one more move. We got to isolate x. So we still got rid of this, get rid of this plus 7. Minus 7 on left, minus 7 on right. X equals 2. Problem over. Okay, we've got 2 problems in the bag. What if we give now a little bit harder problem? Nothing terrible, a little bit harder. Problem number 3. Okay, here we go. What about minus 3 times w minus 4, followed by plus, that's all in parentheses as you can see, plus 5 equals 10 minus, and then another w in parentheses, w plus 1. Okay, we've got to clean up the left and clean up the right before we can even get rid of one of the w's. In this problem, everything was cleaned up. There was no like terms or anything like that. We just had x's on both sides. We had to go after one of the x's. Here we've got more stuff going on. We got to clean it up, the left side and the right side, simplify everything, reduce everything, and then we can look at the 2 w's. All right, so this minus 3 is trying to multiply the w. It's just everything in the parentheses, so it's distributed across the parentheses. We get minus 3w. Minus 3 times minus 4, minus times minus is a plus, so it's plus 12. Plus 5. Okay, while I'm there, might as well take care of the right-hand side too. This minus is operating on the parentheses. It's going to switch all the signs in the parentheses. Well, both are positive, so both now turn into negative. This turns into negative w, and this plus 1 turns into negative 1. Right? Again, let me cordon that off. Okay, now it's still not cleaned up because I got like terms on this side and on this side. So let me keep cleaning. Minus 3w plus 17 equals 10 and negative 1 is going to be 9 minus w, right? 10 and minus 1 is going to be 9 and then minus w. Now we got w's on both sides. Got to get rid of 1. I usually go after the smaller one. That's the usual habit. Let me move this paper up so you can see what I'm doing, and we have some more room on the bottom there. Okay, so I've got two w's, one on both sides. I'm going after the smaller one. You can go after either one. I'm going to have to go after the smaller one. This has got to go. Plus w, that'll go. But whatever you do to the right side, you got to do to the left side. All right, what's minus 3w plus w? It's minus 2w plus 17 equal 9. Okay, minus 17 on the left, minus 17 on the right, because now our job is to isolate w. This is gone. I need more room, so I'm going up over here on the right hand side. Minus 17 on both sides. The plus 17 and this is minus 17 is gone. What's left on the left hand side? Minus 2w, right? That's all that's left on the left hand side is minus 2w. And what is 9 and negative 17? 17 minus 9 is 8. And keep the sign a little larger. The larger number was negative. It wins. So the result is also negative. Okay, here comes the last move. I got to isolate w itself, right? So I got to, what's the coefficient of w? Negative 2. Divide by that exact same negative 2 on the left side. Whatever you do to the left, you do to the right. This is gone, right? They just cancel out, become positive 1, so 1 I don't need. W. Negative divided by negative is positive, so we have 8 divided by 2 is 4. W is equal to 4, and this problem number 3 is over. It took some time, but it is over. Okay, now I've got a whole bunch of space over here that I can show you two strange problems, but we need to be exposed to these two strange problems. Here's problem number 4. This strange problem number 1, 3 times 2x minus 1 on the left-hand side equals 2 times 3x minus 2. 2 times 3x minus 2, just in case this happens to you. You're going to see something strange going to happen here. Okay, distribute the 3 across the parentheses. Let's do our multiplication. Distribute across the parentheses. So 3 times 2x is 6x. 3 times negative 1 is negative 3. 2 times 3x is 6x, right? Distribute this one across the parentheses also. And 2 times negative 2 is negative 4. Okay. Can't have x's on both sides, so I got to get rid of one of them. Either one is good. I'm going to get rid of negative 6x. Whatever I do to the right, I do to the left. You can see something very strange is going to happen. This is gone, and this is gone. On the left, it says negative 3. On the right, it says negative 4. So what do you conclude from this? You have a contradiction here. So if you have a contradiction, then the answer is either call the answer a contradiction. Either that's on your answer sheet, a contradiction, or the fancier way, and the more likely that'll be on your on Alex or on a test, would be the null set, the empty set, nothing there. Also known as looks like this. So those are the possibilities that you'll see for a problem like this. Okay, there's one more type of problem that I want to expose you to as far as this is concerned. As far as this stuff is concerned, let's see. First, let me see if I have any extra room upstairs. And then I don't have to go to another sheet. I do have some extra room upstairs. Right over here. This should do it. This piece of our parchment, so to speak, should do the job. Here's the question. What if you have 3 times 2x minus 1, 2x minus 1 equals 2 times 3x minus 2 in parentheses, and then a plus 1. Okay, so watch this carefully. It's not a big deal, but watch this carefully. So what we're going to have over here is that 3 times 2x is going to be 6x. 3 times negative 1 is negative 3 equals 2 times 3x is 6x. 2 times negative 2 is negative 4 plus 1. Okay, so now what is negative 4 plus 1? It's going to be negative 3. So we have 6x minus 3. Do the like terms on the right-hand side. We have 6x minus 3. Got to get rid of one of the 6x's, so we do. And do minus 6x on right, minus 6 on left. Or you could have started from the left and gone to the right. It doesn't matter. They cancel. Something strange is going to happen. Agreed. But it's different than what would happen before. Now they're actually equal. If they don't come out to be a contradiction, but they come out to be actually equal, then this is what you look for on your answer sheet. This is what you look for on your answer sheet. You look for that this equation is an identity. That's what you look for on it. Or you look for that the solution set is the set of all real numbers. Set of all real numbers. Those are the two things that you'd be looking for. So over here, you're either looking for A, contradiction, B, this little empty looking set there, or C, this symbol. And then that's in that case when there's a contradiction. And when they're actually equal, either you look for this thing that says it's an identity or that it's the set of all real numbers. Okay, so that is this page really takes up all the information we need to know about normal regular equations. The place where we need to go next is where we're dealing with fractions inside the equation. I got to show you what I mean. It sounds a little complicated, but it's not such a big deal. I think you'll agree. Okay, so maybe I can go to page 2 before I end the video. And I won't necessarily have to end the video yet. Let's see. See if it works. Okay, so let me now show you how to deal with fractional linear equations with fractions, right? So we're still dealing with linear equations, but it's got fractions. Okay, let me show you how that works. Here's problem number 1. Let's say you have m negative 2 over 5 minus, and I'm purposely leaving some space here. You'll see why I'm leaving some space over here a little bit later. Just bear with me. It might not look like that on your paper, all that space, but I've got it there. I've got left some space there. Then an equal sign, and again purposely leaving a little space for myself for later. M plus 5 over 15 plus 2. Okay, so we've got a linear equation here. It's got an m. It's not an m squared. We'll talk about quadratic equations pretty soon, but there's no m squared here or anything like that. So it's a linear equation, but it's got a fraction in it. It's got fractions 5, 2, and 15. What is the lowest common denominator of 5, 2, and 15? What's the lowest number that all of these could go into? The answer is 30. 2, 5, and 15 go into 30. As soon as you figure that out, you multiply every single one by 30. Soon every single piece of this, all 4 of them, by 30, including the last one, by 30. Where will that get you? Look at this. 5 goes into 30 6 times. 2 goes into 30 15 times. 15 goes into 30 twice. And 2 times 30 will be 60. Where does that get us? That gets us to the next line. Now, I'm afraid of running out of time on this video, so I'm going to show it to you in the next video. We'll do it again, and I'll show it to you again. Sometimes I'm going to have to do this because there's time constraints on these videos. I got to get them to YouTube so you can see them all semester.